Welcome to the Ad Astra podcast. Today we have with us researcher Samuel Gessner. Welcome. Samuel is working currently in the Observatoire of Paris, l'Observatoire de Paris, in the project ALPHA, which studies the functioning and the spreading of Alphonsine tables, and is a project funded by the European Research Council. Well, welcome, Samuel.
Thanks for having me.
Yes. Well, it's a pleasure.
It's a pleasure.
Since you are not only a very good researcher, but also our dear friend and colleague. So
yeah. So it is really indeed a pleasure to have you here. So today we are talking about the relationship of astronomical instruments and astrology. And you have researched, in the last years, your main research has been on instruments of every kind. So do you want to tell us a little bit about your line of research and what you're doing now?
Yes, so thank you for having me. It's indeed a great pleasure to talk to you and to pick up so many conversations we've had.
Yes.
So yes, my main interests are mathematical and astronomical instruments from the Middle Ages and the early modern time. And actually, this was not my main topic when I started out in history of science and history of mathematics. I became aware of the importance of culture for history only after my PhD thesis. When I discovered that instruments constitute actually a kind of primary sources that one could exploit, I was really fascinated because beyond the textual sources, we have actually objects from the Middle Ages, very few, from the early modern times, from the 16th century. There's a nice number of them. So objects that come down from those times. And there's a special thrill to handling objects that actually were touched by the very persons and astronomers and teachers, students we are interested in.
Yes, yes, indeed.
yes, it's like a direct link between us and them.
Yeah,
that's it. But on the other hand, it's also very tricky to use those objects as the basis for your research, because obviously each object has had its own trajectory and has perhaps been changed and has lost perhaps its original state. And we usually don't know exactly who has used the instrument and how and for what purpose. So there's also the presence of these objects is first of all just asking a lot of questions. It means that we realize how little we know about the actual practice of astronomers back then. There are many instruments we don't know why they were produced and for what purpose exactly.
Mm-hmm.
So
understand their function, the way they function, the theoretical reasons, their connection to other parts of astronomy we know, the way their place in the astronomical culture of the time is an open question. It needs to be researched.
when we talk about instruments, several instruments, which instruments are we talking about?
So the queen of the instruments, I don't know, the king, would be the astrolabe. The astrolabe, everybody's heard of the astrolabe. We're talking about the planispheric astrolabe. Probably the single most successful mathematical instruments of all time. Its lifespan is enormous. I mean, it has been used in several cultural eras over, well, more than a millennium. So this is the most important one. Next comes the sphere. Armillary spheres are very common in the Latin Middle Ages because they were used at universities. There are documents showing this for teaching, for in classes about astronomy, elementary astronomy. Roscoe's treatise contains a chapter that is not much more than the description of such a material instrument. But armillary spheres were used in other contexts. There are Sanskrit texts on armillary spheres, and of course texts in Arabic. So this is also an instrument that is very that has spread around. Now recently I've started to work on less known instruments, less well-known instruments, and the first of these, for me at least, were planetary clocks. So perhaps you can be surprised to hear that I'm saying planetary clocks are instruments, because, well, a clock is, a clock is an instrument, it would be an instrument to measure time. But a planetary clock is not there to measure time, or not human time. It's a kind of cosmic time that a planetary clock shows on various dials, or on one dial, the positions of the planets, the moon and the sun. And it's a clock because it's self-moving, because certain technological features remind us of an old church clock. But the essential part is the mechanization of planetary models. And so in that sense, it's it comes close to a self-moving computing instrument.
Yes, and it's also an art object. They are normally beautiful, very, very artistic. You know, for a moment when you said planetary clocks, I thought you were talking about equatorium. But now I see the difference now. Okay.
There is a close connection that becomes evident when you look at such a clock. I don't know whether I can share my screen to show one of these.
Okay.
So this is a planetary clock from the 16th century, built around 1560. Castle. And in a German country, Hessen. And if you look at the dials, at least the one on the right-hand side, these dials closely resemble the traditional type of equatoria. So you have
there is a connection.
Yes, exactly. You have a different disk that is slightly eccentric, and what you see very well is the epicycle. So the final position of each planet is given as a result of two movements: the movement of the deferent and that carries the epicycle, and the movement on the epicycle.
Yeah, I think we will explain briefly what is.
Yeah.
Yeah, interesting. Not only they are amazing, scientifically speaking, but they are also very beautiful. They are art in themselves.
Yeah. And a precious object, I would suppose, because all of that we're seeing, it's gold and silver, I would imagine. So
you're absolutely right. So there was a huge investment in such objects, not only in terms of intellectual and engineering effort, in terms of labor, of course, and artistic imagination. And this tells us about the audience for those objects. So who was interested, or whose interest could be captured by these topics, planetary movements, and it shows us also the importance that certain princes attached to this field of knowledge. Otherwise, we wouldn't have spent so much money on this.
Yes,
the importance and the respect that they would deserve from people who are dealing with it.
Yes, that it's a wonderful object. I think it's the beginnings of a portable computer that can calculate any astronomical position, and but at the same time, so it's, as you said, an engineering feat in itself to make a mechanism that can do all these calculations with a good degree of accuracy. And then it's not just a mechanical object, it's also a work of art in the sense of the decoration. And I had the opportunity already to see up close some of these dials. And it's a precious object, and it's a work of art. So
and certainly there was a very strong symbolic aspect also to it. Here we can only rely on historical interpretation, of course, but it's very exclusive to possess such an object. And imagine it's like a microcosm. It's an object that moves according to the movements of the whole world. And ideally, if it's adjusted, it has to be readjusted every day at noon according with the sun. If you do that, you have an object that aligns with all with all the sidereal objects in the heavens.
Like holding the universe in your hands. It's the same with the Astrolabe. Also the same idea with the Armillary sphere. It's like you're holding the universe.
In this case, one that moves by itself.
Like a moving universe. It's amazing.
Something that we easily have in an application in a smartphone or in the computer. And here we're seeing the great grandfather of all of that.
Yes, they are the great grandfathers of computers and smartphones. And today we have applications, and people don't even normally they regard them as kind of entertainment, something like entertainment, like very interesting and entertainment, and not as this kind of very symbolically rich objects as the ones that you have just shown. Yes, maybe we can talk a little bit about the Armillary sphere, because I have seen it and I want to go there. Could you explain how it works, what it represents, please?
Yes. So maybe for this,
I'll share that.
Anyway, as I said, the Armillary sphere is a quite well-known instrument, and it has been used extensively throughout the Middle Ages, even in the early modern times, and the production went on actually until the early 19th century. Today, the Armillary spheres that you can find, like this one, which is a modern replica, they're harder to find. There are some cardboard models, etc., because the demand has strongly gone down. But until 1800, there was still use, and many libraries, many schools would use. So why was this so convenient as an instrument and so much demand? Because the curriculum included notions of the basic notions of spherical astronomy, and the Armillary spheres represents or has a kind of materialization of concepts that are that are sometimes difficult to imagine, especially for persons who have a not so strong geometrical imagination. Materialization that that you can touch, and beyond that, beyond the concepts, you can demonstrate how these concepts, various concepts, connect. So, of course, you are familiar with the idea of what is the horizon in a certain place, what is the meridian circle for a given place, what is the celestial equator, what is the circle of the ecliptic. And these were the basic notions that you would have to learn. The nice thing with an instrument that you can touch is that you can fix this in your memory in a very efficient way.
Yeah, we can play around with it, really. You can,
exactly.
You can experiment. Exactly. Yeah.
Can you point out the main components of the...
Yes. So can you...
We can see it, yes.
Yes,
I have
we can
it.
see it quite well. Yeah.
Actually, the actual sphere is just this part. And here you have this broad ring around. That's the meridian circle. It's a fixed meridian circle.
Let me just say
inside this meridian circle.
Samuel, let me just say something. For people who are not familiar with the sphere, the small sphere in the center is Earth. So this is,
yes.
Yeah, this is a geocentric model because this is how we see the universe. We are
from Earth, yeah.
From Earth looking at the universe. That's just something that for people who are not familiar, I think this is kind of important to say. Please go on.
Perhaps that's the first step, yes. The sphere really represents the way people looked at the world back then. And the idea is that the whole world resembles a sphere. And we on Earth, we are somehow in the center of this whole sphere. Now, when you take this sphere as a model of the world, that means that we are in the center, and the representation is like God's view of the whole world. Outside on it. So why this idea that the whole world is a sphere? Well, it's perhaps quite an intuitive picture or intuitive analogy, because when you look at the night sky, you see the stars moving like on a large sphere, and movement that is very slow. It makes one revolution per day is still quite visible. So the movement with the sphere, this daily movement, you can represent by a rotation of this cage. The sphere is here represented by this cage of various circles. And this movement represents simply the daily movement of all the stars and the planets and the sun there that's fixed on this. And now I've inserted actually this sphere into a horizontal ring, and this horizontal ring represents the horizon, the local horizon of of a certain place. And on the celestial sphere that is moving, you can see the main circles. So that was your question. You have here, I'm trying to point with my pencil. You see the equator.
Mm-hmm.
And parallel to this, you have two thinner rings that represent the tropic circles.
Mm-hmm.
Tropic of Capricorn, Tropic of Cancer. And the ring, this little brother ring, that is slanted with respect to the equator, represents the zodiac. And so this is, of course, one of the fundamental circles for the astronomers with respect to this, the zodiac, with respect to the ecliptic circle in the middle of the zodiac.
Mm-hmm.
The astronomers would fix the positions of the planets, measure the positions of planets and the sun and the moon.
Mm-hmm. Mm-hmm. And how far can we do the calculation? So we can use the Armillary sphere to more or less predict the movement of certain planets if we know where to place them in the ecliptic. Would you be able to calculate houses from an Armillary sphere?
You can't determine all the houses with an Armillary sphere, but what you can determine is the ascendant.
Mm-hmm.
And this is, of course, one of the first and most important things that one would like to do.
Mm-hmm. Yeah.
But probably before you would move to such an operation, you would do some simpler stuff like showing how the heavens change according to the latitude where you are, because this is something that people noticed, of course, according to the climate, as they said. You see different stars, the sun is rising higher.
Mm-hmm.
This obviously had an influence on the life in these regions. So when you're in a southern region, you have more heat and the sun has a stronger effect. When you're in the northern region, you get the colder weather in general, and the day length is changing much more strongly.
Mm-hmm.
These are things that can be geometrically shown by the sphere, in a kind of very simple way. We can call it armchair traveling, to make a journey to the pole, and see what you would experience, how you would see the heavens when you're at the North Pole. So to do this, we just adjust the position of the Armillary sphere within the horizon.
Mm-hmm.
So in this position, you're in the position at the North Pole, and as the heavens turn around the Earth, you can perfectly well observe what happens. So when during the year, as long as the sun is somewhere on the ecliptic above, in the upper part of the ecliptic, it never sets. The sun
sets, exactly. That's the midnight sun. And
it's exactly, you have actually one day that starts at the equinox of spring, and the one night that starts at the autumn equinox. So the sun is once 6 months above the horizon and 6 months below the horizon. And then you travel to the equator very quickly, and you have a different experience. Here, the days are always of 12 hours, 12 hours. Never changes wherever the sun is. Day length never changes. The sun always rises perpendicularly to the horizon. And of course, then you would move to a place that you're more familiar with. Once you've more confidence in the instrument that it actually can show you interesting things, then you would like to see what happens when you're, for instance, in Paris. So in Paris is nearly 59 degrees in latitude, so that would correspond.
Where do you measure the latitude on top? Yes, there.
Yes, latitude is equivalent to the height of the pole, altitude. So on this scale here, here we have a scale for zenith, for the height of the pole.
The height of the pole, yeah.
So Lisbon is 39. So the difference between Paris and Lisbon, it is here. And now we're 39. Sorry, I moved a little too much. 39 is that, and 49. Yeah. Just 10 degrees difference.
Yeah, you can see that
still
there is a significant difference in terms of the inclinations. Yes, quite. Yeah.
So
And so, of course, also the astrologers were aware of this difference, and they knew that this inclination would have an impact on the ascendant you get for a certain time.
Yeah.
Yes. What we would see in different latitudes would be the sun and the planets, of course, rising higher or lower, whether we are further up in the north or closer to the equator. That is also what this explains is why some of the signs rise faster than others, because some of them are not as perpendicular to Earth as others. So this is very, for people who are within the context, when they understand what this means, this would explain everything. This would help them to visualize the universe as it is seen from our perspective, from Earth.
And as you said before at the beginning, this would be a very basic level of knowledge. The Sphere of Sacrobosco, which is a book which is everywhere until the early modern period, it explains exactly these basic principles, this mechanism of how the universe changes.
But still, one thing I find amazing in these instruments is that they require from us imagination. And I mean it etymologically, in the sense of being able to create images, imagination. So we have to actually bring them inside and really understand them, and then we can almost make them work inside our minds. We can see them rolling. So imagination in this sense, not in the sense that we normally give it today, but in the etymological sense, it's something that is required. We need to understand this 3D universe, this 3D geocentric model, and then be able to work with it in different latitudes at different times of the day, different conditions. So it's really amazing. Although it's simple, as Luis just said, it is a simple thing, but at the same time, it requires a specific type of approach, a specific type of understanding in order to understand. It's interesting because with computers, we don't have this. The computer
does everything,
does everything for us, yes. So it's very good.
Well, it's interesting what you say. Also, because it's difficult to historically reconstruct what people imagined at a different time when the visual codes, the place of geometry in the curriculum was very different from ours. We shouldn't forget that, one can say all along the Middle Ages at the university, the mathematical were not that much central. The main emphasis went on dialectics and rhetoric. That seemed more apt to prepare the persons to the really important things like theology, philosophy, and physics. So the astronomers, as I become more and more aware back then, they would have a quite practical approach to astronomy at the beginning. So if you wanted to compute the positions of the planets, you would probably first turn just to tables. And you can compute the positions and cast a horoscope without actually representing this.
Yes, absolutely.
An instrument or even in your mind, geometrical. You can get very good results and precise results just using the computation.
Yeah.
So what is amazing is that as time goes, so 14th, 15th, and 16th century, we find once and again attempts and ideas to visualize these computations and these concepts. Does it seem that these efforts, the creation of these instruments, came out of necessity? Because actually the best way and the most exact positions you would still get by using the tables. Using an instrument yields positions that are less accurate. With less digits, if you want, you can determine things to a degree or half or a third of a degree if your instrument is well made. So the turning to the interest for objects that materialize and they represent these concepts in a visual and geometric way is actually telling us something about specific expectations the scholars had in trying to make sense geometrically of what they were doing when compared with the tables.
Yes.
This is an insight that I've more and more acquired over the last year or so when working in the ALPHA project. Is really the kind of reference, the main corrective, if you want, of the historical astronomers seems to have been the tables. They really trusted them. And based on this, they made an effort to reconcile some problems that emerged with the tables. They tried to figure out various ways in getting to grips with this and really understand what lies behind. One could say, in a stark contrast with the who used astronomy, who used geometry and geometrical ideas to produce tables, the Alphonsine astronomers, they did the reverse. They received the tables from the tradition and tried to derive geometry from the models behind them.
Yes, I was not talking about mathematical calculations. It's just the ability to visualize. Probably the tables and the instruments, they respond to different requirements, different needs. And the question I would like to ask you is, how do they interact? And I ask you this because I have seen in manuscripts that sometimes they see the tables and then they go to the instruments, or vice versa. So they can kind of, they may use them both. So what do you think, how do you think they would reconcile, if reconciliation is needed, with these two ways of looking at the universe or measuring the universe?
Absolutely. There's what you say is absolutely true. I've seen this also, that there seems in general a great openness towards different alternative approaches to the same task. Not always is there a kind of attempt to make a triage, or to kind of say that's the best way and these are less well. Often we just get expositions of various methods to do things, and there's an interest in collecting the various methods, in keeping the memory of alternative approaches to the same thing. And I think this is true also in the way instruments and tables coexist. So to take the example of domification. So you can use the tables to find the cusps, or even the oblique ascension. Of course, there's a table for oblique ascension. There's various tables for each climate or several latitudes. You can do it with tables. You can also do it using an astrolabe. And often, well, according to what the actor would require, his expectation, but also it's a question of ease and easiness, quickness. You would do one or the other, but I would say this is not entirely elucidated, this whole question. So in what way various approaches coexist and how they correlate, whether astronomers wanted to see them as totally equivalent, or whether they were aware of the differences. As I said, using an instrument would lead to results, precision of a degree, or some fractions of degrees, while using the table can give you results to the minute.
But it is interesting that when we see the image of the astrologer, so the astrologer / astronomer here, don't have, so the person who is versed on the science of the stars, there's always this, in one hand you have an appraisal for their mathematical knowledge. So the more acquainted that they are with mathematical practices, the more able they are in mathematics, that is equated to better calculations, better predictions, even a better practice of astrology. But at the same time, you have these people, when there's a representation, you always have not only the book, which is a symbol of knowledge, but it can also be a representation of the table. So the knowledge, the mathematics, and then you have the instruments always.
They hold the astrolabe.
The astrolabe, the Armillary sphere, you always have the instruments present. So there is a sort of equivalence here in symbol and status of the knowledge, which is the tables and the mathematics, and then the instruments that allow us to the practice, perhaps. And it is interesting, and I think it's a very interesting question. To what extent is one thing dependent on the other? What is the practice?
How do they interact? Yeah,
do they really use the astrolabe that much once you have proper tables? How does it work? And I think I had the impression, and of course this is things to verify with studies, that most of the times the instruments and the tables in a certain extent are also an instrument of sorts, are always used to make quick measurements, rapid calculations, in which you don't want to spend a couple of hours perhaps doing the math if you don't need to. So if you need something which is quick but accurate enough, you would perhaps resort to an instrument. And I'm putting this as an hypothesis, while if you want something which has to be really calculated with extremely precision, then perhaps you would sit down and spend a couple of hours doing the whole mathematics required for reaching those conclusions. What's your idea? What's your perception so far? I know this is an unanswered question, but what's your view on that?
Yeah, I'm very keen always to see, to find some hints about this use of instruments, use of tables, and they're very rare, actually. The passages in the sources that tell you something about this. I remember one passage in the John of Ligniere's canons on the Alphonsine tables, and there's an explicit mention when it comes to compute the oblique ascension of the moon. It's in preparation of an eclipse computation, and Ligniere says you can get it from an astrolabe, or you can do it in a more elaborate way if you want. But we will use the easier way with instruments. So I think your assessment is very probable that one can use these both methods. Arithmetics, instrumental approach, so to test maybe the results you get, the probability of testing. We shouldn't forget that computing with tables is very hazardous. There's so many steps you have to go through. It's very easy to get a step wrong. At some point you should subtract, but you add, etc. And it can lead astray very easily. So it's actually good to have kind of like an independent check of your arithmetic computation by using an instrument, an equatorium instrument, for instance, would help you. And vice versa, an instrument like an equatorium can also help you to understand, help you to fix in your memory what steps are needed in your computation. That is there are quite explicit passages in this in the Theorica Planetarum written by Campanus in the 13th century, where Campanus says, well, I will explain the various movements and spheres of each planet, and I will also describe an instrument that will make you aware of the reasons why you go through certain steps when you do the tables. So the instrument is not always just there to actually obtain values, but it can have this function of justification of computational steps.
Yeah.
Yes.
Yeah.
They work like they complement each other in a way.
Yes, because I'm thinking planetary positions, you always have to resort to tables. Well, you can go outside and measure them, but if they're not visible at one point, you need the tables to know the position. And of course, having an instrument that can confirm or at least assist you with that, I think it's precious and it's useful. So like you said, that idea that you're using the mathematics and then you're using the instrument to confirm if you're doing the mathematics correctly and properly, if you're reaching the same conclusion or something approximate, I think it's very interesting, like a verification process of the calculation. Yeah.
One thing you said, it's also very interesting. It applies to astrolabes. I don't know if it applies to armillary spheres. It's the astrolabes were made of different materials. We had the great expensive ones in metal, brass, and we had some probably in wood, I don't know, some made of cardboard. So they were made for different types of buyers or public, or they were made by people themselves, students themselves. They probably would do something in cardboard. What about the armillary spheres? It's more difficult to make them in any other material except metal. So would you say they were more expensive? They were more difficult to find than astrolabes, or what would you say about this? What's your take on this?
Very good question. Yes, indeed. I think there are quite some more astrolabes from early times than armillary spheres. Probably also as a consequence of just the fragility of something that is
3D, yes,
dimensional and with sometimes frail rings. You can build an armillary sphere using wood, and there are armillary spheres from the 18th century built in wood. But yeah, it's probably more of an investment. The astrolabe is more interesting because you can go a little further in the computations you can do with an astrolabe than with an armillary sphere. We've said with an armillary sphere you can compute the length of the day, the rising times. You can determine the ascendant and mid-heavens if you want, not the other houses. With an astrolabe, you can do more. You can, there's of course, it combines an alidade that allows you to take the height of a star, or at least of the sun. Taking the height of a star is tricky.
It is.
As we've experienced. The stars are very small and difficult to spot through the pinholes, but let a sun ray through the alidade is easy. And so you can use this and determine the local solar time, and you can do all you can do with an armillary sphere, but beyond that, tell the time and divide the houses at least according to some of the traditional methods. And usually called the alcabetius.
Yes, the standard method.
The so-called alcabetius, yes.
Yeah.
So the astrolabe was easier to achieve, to build in different, less expensive materials, and it allows more operations. That's what you're saying. It allows more.
I think there is it's very, very attractive in that sense, because it goes a little beyond the very fundamental notions that are on the sphere. You have to know these fundamental notions before you use the astrolabe. But then, yes, you can go a little further, because you can you can tell the time and divide the houses, things that you can't do with a sphere. And it's flat. I think
that's what I was
the flatness of the object means. Don't know whether it's easier to construct, because there's still a lot of arcs in drawn and scales to be divided. It's tricky to produce in that sense, but it's flat and it will survive better.
Better, yes. But just for people who are not familiar with these instruments, although they are so different, apparently, they basically represent the same reality. They represent this geocentric universe with everything revolving around our point of view, our Earth. So one of them is 3D and the other one is flat, but they actually represent the same reality. Although, as you just said, the Astrolabe allows more operations, more calculations. But now I'm thinking, is it because the Astrolabe is easier to carry and everything, could the sphere be more strongly symbolic or even artistic, and the Astrolabe more functional, more practical? What do you think?
I think both probably, as you said at the beginning, symbolically they are quite equivalent. In both cases, you carry the universe in your hands, and the movements of the heavens and their impact on life on Earth is somehow symbolized and shown by those. The Astrolabe has perhaps a longer history and more variation in them. In both, one thing that I've been fascinated by is that that there is, of course, there is a concept of what an Astrolabe is, a plane sphere, a flat sphere, but when the makers made their instrument, they would often combine additional functions that go beyond just the basic minimal set of ideas. So what is very common on Western astrolabes is, for instance, to find a shadow square on the back.
Yeah.
Mm-hmm.
You find other astrolabes with scales to convert equal to unequal hours, and vice versa. Also, by the way, an operation that is important for in astrology, because as you remember, the unequal hours are the planetary hours.
Mm-hmm. Mm-hmm.
All the planetary movements, however, are computed in equal hours.
Mm-hmm.
So you would, to determine the positions of the planets and the moon and the ascendant, you would use equal hours. But then you would need to go back to planetary hours if you wanted to know that, or vice versa. If you use the astrolabe to tell the time, usually you get the time in unequal hours, that then you would have to convert into equal hours to compute the planetary positions for that very moment. These scales, and in some cases, one instrument that is held at the Museum of Science in Oxford has been described by Seb Falk, is an astrolabe with an equatorium on the backside. So you can combine things on one instrument. I think this has also been one of perhaps the driving forces. Yeah. One innovation that in this context is important for us here is also to think that from the end of the 15th century or around 1500, astrolabes began to include the house division according to Regiomontanus, the system. And these astrolabes, they include a new set of lines that curved lines, arcs of circle, that converge on the south point of the horizon.
Yeah, yeah. Facilitating.
These lines didn't exist in the earlier astrolabes.
Yeah, and in facilitating computation that otherwise it would take some mathematics to do.
Otherwise, you would need huge tables. Yes.
Yeah. Interesting.
No, they are remarkable instruments, and the spheres also. So yes, I never cease to amaze myself with these instruments.
Yes.
The spheres also have some evolutions and some variations, and I've become recently interested in one very rare development of our Armillary spheres. Some of them are built to show the movement of the fixed stars, or the precession of the equinoxes, as we would say.
Mm-hmm. Mm-hmm.
Here next to me doesn't show this, but the Alphonsine astronomers imagined that the fixed stars actually had a threefold movement. It's not just the movement we can see at night when the heavens revolve around us once a day. So that was one movement. There was a second movement. It was a uniform movement of all the stars that would slide on the ecliptic poles, would just produce a shift in the ecliptic longitude of all the fixed stars. Mm-hmm. That's the one we still know. We call it precession of the equinoxes, and they called it the movement of the eighth sphere. Mm-hmm. Then, specifically the Alphonsine tables, they included a third movement. It was so-called movement of trepidation, imagined to be a movement of 2 points near the equinoctial points that turn on two small circles around these equinoctial points on the sphere, around the equinoctial point of the zodiac. And there are about a dozen of such spheres that survive from up to the 17th, early 17th century, that actually are trying to visualize these three movements. And it's interesting that this becomes quite a challenge, to even more difficult than the usual 3D model. This requires usually to produce three Armillary spheres, one including the other, like Russian puppets or
concentric.
Very, yeah, they are amazing.
Yeah. Well, Samuel, I don't want to keep you forever, and it's long. And thank you very much for showing us the Armillary. It's always fabulous to see these instruments, even a reproduction, but that one is
very good.
Quite a good instrument, and it has all the moving parts.
And, I'm always there and ready to show you any computation you want to see.
Yes, we can schedule another podcast for the specifics, because this was like an introduction to the instrument. Yeah. Then we can go to the practical application.
Yeah, that would be very, very interesting to demonstrate some of the practical applications of these instruments.
And of course, we'll be very happy to talk to you again soon, and we'll keep in touch.
Yes,
my pleasure.
Thank you very much.